Now I'm going to pass it over to Siddarth Jain, and I just want to say a big thank you, Siddarth. He's a member of the DORA community. He's participated in several of these lean coffee discussions, and in almost all of our correspondence, in the calendar invites, in these meetings, I ask for members of the community to reach out if they would like to present, and I was really thankful when he reached out and shared. He's an ML engineer by trade, has been working in this space for quite some time, and I'm not sure, he'll probably share more about how long he's been working now on kind of in the SRE space, bringing AI to the SRE space. And so, he's willing to come here and share with us what he's learned, how some things went good, some things they're still working on. And I really appreciate him coming and talking today, and encourage anyone here, if you've got something you're working on, something you can share with the community, we really appreciate it. We've got, at the end of the month, we have another community member that's going to talk about how they're using metrics within their organization. So the more that we can share really all of how this is working in practice, I think the better we can learn and grow together. And with that, I will pass it off to Siddarth.
Okay. Thank you, Amanda, for this introduction. I'll just share my screen and get started with the conversation here. Topic of the conversation today that I'm going to spend some time on is how can folks leverage ML and AI to reduce some level of production incidents that they have within their team. Now, let me just give you the TLDR. In most cases, AI is just a productivity tool that you will see. Specifically in the topic of production incidents, it is not going to do anything automatically or autonomously, as your business heads or your leaders might be pushing that, hey, why isn't AI taken over 50% of the DevOps bandwidth? Why do we still have to hire engineers, etc.? So my TLDR that you'll also see from this conversation is that the direction in which it remains is largely assisted. Some places it would eventually lead to automated, but autonomous is still like a slightly subjective goal when it comes to production incidents. Now, when I say production incidents, I mean it is something that the business cares about and you are asked in the middle of the night to wake up for it. Now, you might say that, hey, look, Kubernetes can get automated. Yes, Kubernetes can get automated, but can a production incident get automated? That's the question that we're going to discuss here. So the first 5 minutes, what I'll do is I'll talk about some of the cases or the case studies that are prevalently available in the market. These are proven places where some level of machine learning is already being used, and that is something that you could take as a starting point to immediately implement without having to worry, is this really super experimental or not? So that is going to be the first part. And then I'll go into the other part, which is, is LLM really useful significantly? Where is LLM really useful? How is it coming into the picture, etc.? So that's where I'll go into the second part of the conversation here. But before that, a very short introduction. Amanda already gave a little bit of overview, but I've been a data scientist and machine learning person since a very long time. And like for the last 2 years, I've been dedicatedly working as a founder at a startup called Doctor Droid. And we've been primarily, like when we started off the company, the whole vision of the name itself is that, create some kind of a bot that can do some level of investigation, etc., or like a doctor of this self-healing systems, right? Like the yada yada. But like that's not something that we've really been able to achieve anywhere close to. But like that's the vision being for the company, and we've tried multiple different ways of solving that problem, and that's where all of my experience I'm trying to share from the experience that I have. What I realized is in production use cases, the way AI and machine learning works is, if you talk to a machine learning engineer and if you go and see their code, you will see that the entire code oftentimes for a model is just like, maybe 200 lines or like couple of files, versus when you look at a backend engineer, their systems are designed with like, 150 files for one microservice to get spun up. The difference primarily comes in because most of the job in machine learning is about, tweaking those parameters. Like there will be like 10 input parameters and 5 output parameters, and you just keep tweaking them left, right, and center until you figure out what works for your use case. Like I've done places where, we had to do face recognition, and then there were cases of face masks being there or not being there and taking exceptions for that, etc. So the primary thing about machine learning that I learned over time was that it can happen well, but only when the context window is significantly restricted. And three cases where I have seen like enterprise level adoption of, machine learning in observability slash in, production incident management are runbook automation, deployments, and alerts. All the three examples, I'll just take you through how they operate. The first one, this is what Microsoft released a paper on. This is like, I think, April this year or December last year. It's called RCA Copilot. Now, the name sounds that this is probably like automated, investigation, but there is some level of, this is like a 15-page detailed, well-written research paper. But when you try to go into the detail to understand, what each of these jargons in this entire, architectural diagram means, what it actually is you have to understand here. First thing, OCE is a on-call engineer. Okay. Now, a handler matching here. So they have an incoming incident that's coming in, and then they have something called a handler matching. So handler matching, although the nomenclature doesn't give you intuitively, it's actually matching an incident from a list of runbooks slash handlers. They call it handlers, but they are just matching it one to them. And each of those runbooks is actually written by an engineer. None of them is actually AI generated in any shape or form. Now, what they're doing after that is they are taking, like, these are, different. If you go through the paper in a little more detail, you'll read that it is empowering on-call engineers to construct incident handlers, which are automated workflows tailored for each alert type, made up of reusable actions reflecting OC's expertise. Like, for instance, checking your Kubernetes log is one such example. These handlers automatically streamline the collection of information. So the information that is the opinion, right, which is what do I need to check, is done by a human with 100% confidence. That data is taken up together and just sent to an LLM for summarization. That is the only use case where they are using LLMs, but they are seeing a significant improvement in one more thing. The other thing that they are doing is they are trying to predict root cause basis the previous data. So they took like 1,000 incidents from the past. Now think about it. Do you have the docs to create those 1,000 incidents? Like, maybe you have good, postmortems, maybe you don't. But you took those 1,000 incidents, you labeled all of them, and then you are trying to categorize them into different possible root cause categories. And then you're creating a predictor of what likely, basis the investigation data that I have, what it likely is. But it really, like, when you think about it, a lot of RCA postmortems are heavily biased basis what we know and what we don't know. Also, they are very retrospective often. Like, sometimes if you write a RCA, like a postmortem in a retrospective way, you always reach the end point in a very sequential manner. So those challenges exist, but this is something which folks have implemented and automated in Microsoft. Now, the second example that I'll talk to you about is deployment tracking and auto rollbacks of deployments. This is something that Slack is done, Microsoft is done, Google Cloud is done. Like, I have friends who have actually built those systems out in those companies, and it's pretty straightforward, to be honest. Like, I was just, like, they have a very complex batch of explanation that they've done here, but I'll just show you. I just wrote a script just in the last some time about how this is done. Basically, I generated a CPU utilization metric for DoorDash, right? And then I created a sinusoidal curve there, which is sort of trying to imitate its demand supply pattern. And then what the Z-score does is you just try to do a standard deviation comparison compared to yesterday as well as last week same day, and try to see whether or not the deviation is high or not. Now, standard deviation is a mathematical calculation that is uh, that helps you identify whether it is in the, what percentile is it within the curve that the data is lying in. And with a very simple logic, you can identify when it is crossing a threshold or not. And the folks, like, you see the Z-score on the right, it basically says how much is your mean of the last 5 minutes deviating from the standard deviation that you have for your system currently, right? So if you can calculate this score, so basically this is just one small Python script. You could pick up something like this, use the information that they've already given in the Slack blog or in the Azure paper that there is for this. And you just set up a rule on it that, hey, for my deployments, every time there's a deployment, trigger this script, which has these 7 important metrics which are related to my business. Check it every 5 minutes for the next 4 hours. And if you find any anomaly in it, then just let me know that, the Z score is violated there. And Z score is slightly more dynamic than an actual threshold because it is being calculated on the go, and it depends on the recent mean and the variance of the data. It is not a statistically constant number there. So that's the second approach that folks have done frequently enough and gotten fair bit of success there. The third one is the easiest of the lot, which is trying to be able to do like alert correlation and analysis, which is you have 250 alerts, but grouping them together by their title, grouping them together by some keywords, and a little bit of NLP actually solves that problem, so that you are able to see. We built this out internally when we had some such similar challenge, and it's like uh, you know like we basically would track by the titles which are similar alerts, and group them together and show the count of which new alerts have started coming up in the system and which older alerts have started subsiding. So whenever an engineer would see that alert, they would feel like, now do I need to reduce that alert or not? They get the cue right there. I'm sorry, I missed putting it on screen share before, slideshow before, but yeah. So this is primarily, I think, the 3 core use cases where folks can actually get immediate value from little bit of leverage of AI or machine learning or the concepts such they are. Right now, I'll get to one experiment that we did, because we would, like, I was also trying to experiment all the while that, hey, I'm trying to solve these problems, and the biggest problem is everybody needs to debug their issues constantly. Like, can I try to do something that can significantly offload the burden for the engineers there? And I'll show you a demo, but what you'll realize is that there is a lot of there's a lot of data just in terms of the metrics. Let me just show you a demo first. The first thing I do is, the way I set up this demo, the experiment that I did is, every time there's an alert that's run, yeah, so every time there's an alert that's received in my Slack channel, it will automatically go and try to figure out from the context of that alert, what is the possible set of steps that the engineer should be taking to figure out what's the issue here. So now I have received this alert here saying, triggered, this event has an abnormal change in latency. Now I'll show you the result of what the automated analysis shows. But in the meantime, what I'm trying to say is that there are 3 major challenges that I saw. The first one being that it really lacks the business context in terms of the problem itself and the architecture of the system. So it recommends super generic steps. And then there's a risk of hallucination in terms of, uh, let me see if the, yeah. So as you can see here, there is a playbook that is created and published here that automatically comes up here. And it basically has the steps. Now it says the alert was for ingest service for a specific, for specific API v1. So it says, go and check the dashboard for service ingest for any anomaly. Then check the APM trace for that specific endpoint to see if there is any anomaly there. Then it says, go and check the underlying infrastructure provider, go and check for CPU, memory utilization, network issues. Yeah. Then, yeah. So if you see the steps that it actually recommends is kind of generic compared to, let's say, what an engineer would actually write. Now, this is the actual, the place where this entire experiment is run. This is the actual playbook that the engineers created from that team. And what they say is, if there's an increase in the throughput compared to same day last, same time last day or same time last week, then just increase the pod count. Now, to make such an opinionated statement, what does the engineer know? The first thing is, engineer has the context here that, hey, this business is actually a event ingestion platform, and for them, latency matters as much as throughput. So if your throughput increases, it means that the client is having higher volume of events, and I need to let them manage it because that's my business as a like an event analytics platform. So that's why the opinion is very opinionated that if you see a high end throughput, just increase the pods because that is my business goal. That is my business prerogative to manage it. If this was an internal service, it might have been a different setup. It might have been a different, objective there. The second thing is it is saying very specific metrics that it asks you to check instead of saying go and, go and check the entire traces, go and check all the cloud metrics. So it is slightly more specific that, go and check the Kafka or don't check it. Right. So that's the primary learning that I had in terms of, when you try to run it using especially, if you try to automate the investigation part. Another learning that I had was, this experiment, the ingest and the V1, all of this is primarily built on is primarily a 4 microservices platform, just 4 microservices with some level of, streaming pipelines in it. And this is the entire architecture where there are a couple of databases, ClickHouse and Postgres. There's a Kafka, there is an ingestion source, and there is a visualization UI. So for just this configuration, there were a total of 2,100 metrics generated across CloudWatch and Datadog. So when you or me as an engineer, I try to think which metric I need to look at it. I have a very, logical tree of thought to see which one to go into versus, and that's one thing that I have a very logical tree of thought. The other thing is I know which infrastructure and which applications are interrelated and at what level. Sometimes it's very subjective that a feature and a infrastructure, are they interrelated or not? Most people might not know, but some engineers would know. Now that context for a machine to be able to get it's slightly significantly far. A, because documentation is not existing. B, because the trace is not as trivial as you might, as a tracing promise might show you if you're an SDE1. But as you grow to SD2, 3, and further on, you realize that no, it's not that trivial to actually do this distinguishing there. So yeah, I think that's been one of my primary learning, that when you actually need to debug, you need 4 things. You need context, you need analytical thinking, you need goal, and you need to be able to be confident if the issue goes downhill. How do you, figure it out and get back up in the game? All of which, for the current set of, machine learning / AI technologies that exist, they still are not at a level at which an engineer can actually do it with the context of 6 months, 12 months within a company.